Hi everyone, welcome to Royal Bengal Chemistry. Today's topic is regioselectivity in alpha beta unsaturated carbonyl compound. Okay, this topic is very important for CSIR NET and guest aspirant because in each and every year this kind of question asked. Okay, now let's check. At first we start with simple carbonyl compound. Okay, in case of simple carbonyl compound, if nucleophile is added, then we know that in more electrophilic center of this system, nucleophile will attack here and goes from this kind of product. Okay, now the beauty is, and more interesting fact is, if some system is alpha beta unsaturated, okay, unsaturated system, here we can check through resonating structure that in this case there are two electrophilic center. Okay, now if when nucleophile will comes, then it can attack in both center, here also, here also. Now we have to understand that when this attack will take place and when this kind of attack will take place. 1 2 3 4, this kind of attack is called 1 2 and this kind of attack is called 1 4. Okay, this kind of phenomenon can be explained with three factor only three factor. Okay, if you understand this three factor, you will solve almost all the problem of kind of regioselectivity. Okay, one factor is SHAB principle, second is temperature, and third and last one is structural. Okay, now in this video I will cover all the problem which can be solved using SHAB principle. Okay, and the next video this part is quite small compared to this, and the next video this part will be completed. Now see very carefully. Okay, this carbonyl carbon in its two resonating structure, okay, resonating structure, two electrophilic center is present. This electrophilic center is directly attached with highly electronegative oxygen moiety. That means it's harder or more electron deficient center, or more electrophilic in nature, and this is comparatively softer. Okay, now according to SHAB principle, we know that hard acid prefer to bind with hard base and soft acid prefer to bind with soft base, and we know nucleophile is electron donor. Okay, that means it will act as a base. Now nature of the nucleophile will decide that is it hard or soft. If it's hard, then it will prefer 1 2 attack, and if it's soft, then it will attack, it will prefer 1 4 attack. Okay, now let's check with some beautiful example. Okay, which Now, in case of nucleophile, what is hard and what is soft? If we can decide with we can predict it with the charge density, okay, or electron density, charge density, okay, as like SH minus sulfur, it's bigger in size, chloride, bromide, iodide, it's bigger in size, okay, that means its charge by size ratio, that means charge density is quite low, that means it's soft nucleophile, soft nucleophile. OH minus, fluoride, okay, hydride, here size of the nucleophile is very small, fluoride very small, hydride it's very small, okay, that means this kind of nucleophile here charge density will be very high, is not it? Charge density will be very high, so it will be hard nucleophile. Okay, now we will solve problem and you will be able to understand within few minutes that when 1-2 attack will happen and when 1-4 attack will take place. First, Me is H, NaOH. Pause the video and try to solve by yourself at first, okay. Here MESH, NaOH, OH minus will attack the most acidic proton and it will gives this kind of nucleophile, okay. Sulfur bigger size, charge density is low, that means it will act as a softer, and here this one is hard center and this one is soft center. According to HSCP principle, soft acid will prefer to bind with soft base, that means 1-4 attack will take place. SME, which is further resonance stabilized, and here OH protonation will take place and we will get 1-4 product, okay. If any doubt arises, then you can mention it on the comment section, okay. Then next problem is HCl. It's also bigger in size, this nucleophile chloride, okay. So it will also give 1-4 product. And what will be the product? This one, right? If we added HBr here, what will be happen? Bromine will attack here because bromine is also bigger in size compared to chloride, that means it's a softer nucleophile and will attack to the softer electrophilic center, right? Another nucleophile, phenyl is H, sulfur bigger in size, charge density is low, that means it's a softer nucleophile. Where it will attack? It will attack on soft electrophilic center, right? Another problem is that This kind of problem always ask in CSIR NET and GATE examination. Okay, now let's check. Here is also an alpha beta unsaturated. This is soft electrophilic center and this is hard electrophilic center. Sulfur bigger nucleophile, where it will attack softer position. Okay, 1,4 adapt. Now phenyl NABH4. I did not proceed through overall mechanism of this kind of reagent. Okay, simply we can tell that this NABH4 gives an hydride. It's an reducing agent. Okay, hydride, small nucleophile, charge density is maximum. Okay, that means it's a hard center, it's a soft center, it's a hard nucleophile. According to HSCP principle, hard acid will prefer to bind with hard base. That means this nucleophile will attack here. Okay. One to product. Lithium aluminium hydride. This nucleophile also, this reagent will also give then hydride. It's an also hard nucleophile. Okay, it's also an reducing agent. This will also attack in more harder position compared to soft. Okay. Now you know what, ethyl, okay, it's like this CH3, it's a Grignard reagent, I think you know. Okay, ethyl, here charge density is high and magnesium 2 plus is attached with this one through ionic interaction, so it's in hard center. It will prefer also hard position. According to HSCP principle, it will gives okay 1 to product. If in this compound we use same reagent with copper chloride 0.1 equivalent, then we get this compound. Why this is so? Let's check. Due to transmetallation of organometallic reaction, we get this kind of intermediate. Okay, now it's a carbanion. It's not actually hard, not actually soft. It depends on the metal. Okay, here metal is harder center, that's why it will act as a hard nucleophile. Here metal is soft, that's why it will act as a soft. This phenomenon is called symbiosis. Okay, this is called also Gilman reagent. Okay, that's why due to attached with copper, it will behave as a soft nucleophile, and soft nucleophile will prefer to bind with soft electrophile according to HSAB principle. Okay, and we get 1,4 product. Okay, this is the concept. On the basis of this kind of simple concept, you will be able to solve almost most of the question. Okay, and another 2 part I am tell previously that I will upload in next video. Okay, now try to solve this question. OET NaH. Okay, what will be happen? This is a base and it will abstract proton from where? Most acidic proton, which is attached with sulfur atom, and we will get this one. Now sulfur, we know sulfur is a bigger in size, that means charge density is low, that means it's softer in nature, that means it will attack on softer electrophilic center. Okay, then after protonation we will get this compound. By the way, this question comes in 2020 November. Okay, 2020 or 2020 November, CSIR NET. If everything is same, okay, only sulfur is replaced with nitrogen, hydrogen, then what will be happen? In the same manner, base will abstract the most acidic proton and we will get here NH minus. Now NH minus, size is low, charge density is high, where it will prefer to attack? It will prefer to attack in heart center. Okay, and we will get 1,2 attack will take place and we will get this kind of product. Okay, another problem is this one. R2NH, and here, okay, remove it. Okay, now here we will get 1,4 product. Now you guys, NHR. Now you will say that in previous question the same amine gives 1,2 product, and down in this case it will give 1,4 product. Why? Okay, why? It's very simple. Look at very carefully. In previous case we use base that will gives us NH, suppose R, this anion. Now we did not use any kind of base. Okay, it's a simple, its lone pair will act as an donor. Okay, donor side. Now here charge density is more, is high, here comparatively low. Okay, now low means softer, high means harder. Now it's harder center, it's softer center. That's why in previous case the hard nucleophile will prefer to bind with hard electrophilic center, which gives us 1,2 product, and here soft nucleophile will gives 1,4 adduct. Okay, understand? If any kind of confusion arises, then please mention it on comment section. Okay. This one, and we using 83N. This one is an combo. Okay, what we will get from this? It will abstract the most acidic proton and formation of enolate, right? Right. Now its resonating stability is like this. Now where it should attack? It's harder center, it's softer center. Where? Try to understand. Okay, it's placed on carbon atom, it can placed on oxygen atom. Both are individually, you can say it's harder, like. Okay, but the beauty is due to conjugation charge density is decreases, right? Charge per unit area is decreases due to conjugation. Okay, that means it becomes softer nucleophile. Okay, now softer nucleophile will attack where? It will attack on soft position. Okay, and we will get this compound. Okay, if we use the enamine, okay, now you can also say that it's delocalizing, it can delocalize. That means charge density is comparatively low. That means it's a softer nucleophile. The softer nucleophile will attack to prefer bind with softer electrophilic center according to HSV principle. That means it will attack in this position, and we will get like this after hydrolysis. After hydrolysis, this can break and imine gives ketone. Okay, another question. here what we will get, this due to minus A effect of oxygen atom, charge density become lower on this oxygen atom. That means it becomes softer. Where it will attack? It will attack on soft position. Okay, concept is same. Okay, just look at it a little bit more carefully. H, okay, and negative charge is here, and you can show the resonating structure. Then it will attack here. So, because it's in high oxidation, it's in most probably, yeah, +1 oxidation state, right? Sorry, we have to calculate this one. Attack here, and this will remove, and we will get this one. Okay. Now another example. Okay, we can use this one. Okay, now its resonating structure is like this, plus minus like this. Okay, that means its charge density is quite low due to the conjugation. Then where it will attack? It will be softer. It will prefer to bind with soft electrophilic center. Okay, and what we will get? We will get this one. Okay. Now this HSAB principle not only applicable in this kind of alpha beta unsaturated carbonyl system only. It can be, this concept is also applicable in other system also. Okay, like this one, CN MENH2, no base is added. Okay, no base is added. That means it will act as a soft nucleophile. That means what we will get? NH, Me and CN. Okay. Now you can solve the problem from previous year question of CSIR NET and GATE, and I am giving you just one homework for this. Okay, let's do this. Is Me2 methyl iodide with an base sodium hydride. Okay, another the same compound is Me2 methyl iodide NaH2. Okay, try to do it yourself. If anyone mention that and this problem is not solvable, then I will make solution in next video. Okay. Okay, by the way, this is my first video. If any kind of that means a speed related issue, okay, any kind of problem arises, then please tell me in the comment section. I will try to recover that problem. Okay, thank you for watching.